Okay. Hello, everyone. Good to see you again. Today's webinar. Today's webinar is the one webinar in the webinar series we call the Microfluidic 101 with Dolomite. So this will be released every last Thursday of each month along 2021. So my name is Ching Nguyen. I'm technical application specialist of Dolomite. So today, the topic we are talking about the chip blocking and how to avoid the chip blockage. So actually, the chip blockage is an event that any microfluidic researcher never want to occur. So unfortunately, so this does happen sometimes, especially when working with narrow channels microfluidic chip and polymeric solution or cell suspension. So today's sections will focus on some way to avoid this painful experience. So today, the webinar agenda will be including a presentation, and after that, we move to demonstrations, and finally, the Q&A section. So during the webinars, if you have any questions, please feel free to write down the question in question box. So we will try to directly answer you to in Q&A section. So today, what we talk about, it would be including what do we need for running microfluidic experiment again, and how to avoid chip blocking while running applications on microfluidic systems, and finally, how to resolve chip if the chip blocking happened. So first, let me remind you about the concept of the microfluidics. We will need three main things for running the experiment with microfluidic. So you need the first is two immiscible fluid, and the second thing you need is a pump. That's a way to moving the fluids. And the third component that you need is the microfluidic device that you can do the microfluidic experiment. So it is our single channel system for Dolomite for large scale use. So it including the pressure pump that can drive the fluid into the microfluidic chip by using the pressure driving concept, and the microfluidic chip connecting with the pressure pump through the tubing and valves, and the microscope with high-speed camera that can visualize all the process inside the microfluidic chip. So the important factors during this section is the chip coating or chip surface chemistry, because it will refer to the way how you can prevent the chip blocking and also how to resolve your chip after if you got the chip blocking. So with the Dolomite microfluidic chip is divided into three standard surface type. So the first is a hydrophilic surface coating. So this is where B27 270 type glass cleaned within our proprietary method. So it's the ultra clean finish. So resulting in a very highly hydrophilic surface which is wetted by water. So the exposed surface chemical group are the hydroxide group. So with the hydrophilic chip, so you use for the continuous phase water, so it's wet property, so it's improving the drop deformation in water suspension, emulsion. The second chip surface chemistry is the hydrophobic. So this is established by applying salinizing agent onto the bare glass surface. So the physics surface has a cell assemblage of the monolayer of the sealant group. So it will rendering the surface as a water repelling. The third one is the fluorophilic. So this coating is achieved by applying a retreat reagent onto the glass surface. So this will allow the aqueous droplet to be created in the fluorinated oils. And the second factor is very important is the chip channel size or chip edge depth. So with the Dolomite, we have a very wiring of chip size, but common chip edge depths are listed in the here with the 5, 14, 15, 100, and 190 micrometer chip channels. So it could be clarified, divided into the two types. One is a small droplet junction chip, which have the chip junction size around 1 and 14 and 13 micrometer. And the second type is a larger chip junction, so it's with 100 and 190 micrometer. So normally, the chip blocking will be very seriously with the small droplet chip junction size, as it's very easy to getting blocked by the contaminant in the solution. For the larger drop junction chip, the chip blocking can be less effective if you have carried very much about the solution before the experiment. So how to avoid chip blocking while running applications in microfluidic systems? So here is showing some chemical compatibility table for chip surface coating. So with 3 types of the chip surface coating, we have a list of the chemical compatibility. For hydrophilics, so almost the solvents that we use, like water, acetone, or some organic solvents, or the alcohol, even though with acidic and the base solution is the very stable, compatible with the hydrophilic surface coating. However, with the hydrophobic and fluorophilics, we have to note about the acidic and the base solution when we use, because the base and the acidic solution can remove the surface coating in the hydrophobic and fluorophilic chip. And to prevent the chip blocking during the experiment, please to following the procedure to clean the chip at the end of the day. So the liquid used should reflect what has been used during the experiment or is miscible with this. For example, like waters or organic solvent or oil, but without the active ingredients. So ingredients. So it means you have to use the blank solvents that you are using during the experiment. That will be fine. And before doing the cleaning procedures as following in the slide, please refer to the chemical compatibility table before cleaning your chips, as maybe some liquids may not be compatible with your chip. So the procedures of protocol for cleaning the chip at the end of the day are listed as below with the 6 steps. So step 1, you should pump the liquids at the solvent in the forward direction in the flow rate of the 1 ml per minute for 5 minutes, but do not exceed the pressure limit of the chip. So normally, all model chip, our Dolomite chip has a limitation of the pressure of 30 bar. So please just do the flushing the solvent in the forward direction in your chip under the limitation of the pressures of your chip. And the step 2, you should stop the pumping and leave for 5 minutes with 5 minutes without flow. So the purpose of this step is to give enough time for solvent to dissolve all of the contaminants or ingredients during your experiment that remained after your experiment. And step 3, after the 5 minutes leaving without the flow, you pumping acetone at the flow rate of 1 ml per minute for 1 minute. So the acetone will flushing all of the remaining solvents, including contaminants that dissolve in the solvent, out of the chip and cleaning the chip surface with the acetone. And the step 4, you pump dry for 1 minute. So this step will be removed all of the remaining acetone that you use in step 3 in out to your chip. So this one you should use just only the air or the inert gas the inert gas suppliers to clean this to do in the to use in this step 4. And step 5 is take off the connectors and ensure that the seal are totally dry before in just keeping storing the chip in the step 6. So you should, after that, you store the chip connector and seal in a dust-free environment, like in just the sample chips box or the dust-free environment like bag, using some nylon bags. Yeah. So actually, to reduce the likelihood of blockage chip from particles, so the things you have to do, you have to, before running experiment, is all the liquid and gases, including any clean solution, it should be filtered before they come into the contact with any part of the microfluidic system. So it can prevent any contaminant, unwanted contaminant that can come inside to the system and cause the blocking the chip. So this should be done even if the chip had the built-in diffuser. So normally with the smaller chip, we have the built-in diffuser before going to the chip channels. So even though with just built-in diffuser, you have to do the filtration before running experiment, because if you do not do so, the contaminant maybe can block the filters before going to the chip. So it also cause the chip, it also destroy the chip. So we suggest that using the very small filter like 0.1 or 0.2 micrometer filter that can filter the dust side less than 0.2 micrometers into the chip. So with the appropriate chemistry to be refilled filters or liquids. Also, we also supply a 2 micrometer inline filter that you can see like in here. So you can integrate with the tubing in your sample vials, sample containers before going to the system. So it is well suited to remove any tiny fibers prior to the chip, and a common called blockage chip. So if the chip is blocked, what we should do actually, if the chip is blocked by any dust-free or contaminant, not 100%, you can make sure that we can restore the chip or resolve the chip to work as a normal condition. But we can try several ways to solve the chip. So in here we suggest the servers a protocol which including just the 3 of the steps as listed below. So as also for just remember, so please before doing this step also need to refer to chemical compatibility table. So maybe you can avoid some liquids not compatible with your chip, and it can destroy the chip during the cleaning step or the blocking step. So the protocol will be including the step 1 just pumps or liquids in reserve the direction. Actually, it's a little bit different way compared to the cleaning chip at the end of the day. In the cleaning chip at the end of the day, you pumping in the forward way at the way you are doing the experiment, like just input connecting the input to the output of the microfluidic chip. But in this way, if the chip blocking, so it means that the contaminant will remain at normally at the chip junctions. So to flushing out the contaminant or dust come out of the chip, you need to connect by the reserve direction. So you should connect from output of chip and pumping from the output of chip to the input of chip. So you can see in here, for example, like the 3D flow focusing chip. So this one is the input and this one is the output. So in this way, we connect the output with those solvents and to flushing out the chip free in this way. And if there's any contaminant in here, so it should be more easily to remove out the chip by pumping in this way. The second step is to do this at the flow rate of the 1 ml per minute for 5 minutes. So just pumping the solvent at 1 ml per minute for 5 minutes, but do not exceed the pressure limit of the chip. So at the same considerations in the clean the step. Step 3 is leaving for 5 minutes without flow. So this one is also similar the concept with the step in cleaning step. So this one, the purpose of this one is just give enough time for the solvent can be dissolved or the contaminant just out by maybe the byproduct or the product during the experiment like polymerizations. So if give enough time, so those solvents can be dissolved on the contaminant and we'll take out the contaminant to the chip. And the step 4 is the pumping in the forward direction. So after 5 minutes leaving without the flow, you just connect your chip in the forward way. So in this case, you do not you connect the input of the solvent with the input of the chip and pumping at the cleaning like the cleaning step. And step 5, just leave 5 minutes without flow is the same step with the step 3. So it's the purpose for is used for the dissolving on the contaminant by using solvent. And step 6 is this repeat the step 1 to 5 if required you feel that the contaminant is not completely take out to the chip. So you need to repeat from step 1 to step 5 again to remove the contaminant. And step 7 is just doing the step same in with the cleaning the step in the cleaning chip at the end of the day. So and store the chip and the connector and all of the component in the dust-free environment. Here, so I would like to introduce you to one very useful kit that can be used for chip flushing or chip reblocking, resolving a block. So it will allow the easy cleaning between chip between the run and the chip the flushing kit provide. So this will allow the chip to be removed from the system, load into the flushing kits. So all the channel can be individually cleaned and ready for the next use without dismantling or disturbing the work of the platform. So basically it would be very simple. It would be including the edge interface with connect with the linear connector or the top interface depending on what type of chip you are using. So if you use the larger drop junction chip, we have edge interface and linear connectors. In case of you use the small drop chip junction, so in this case the chip connection will be kind of the top surface connection interface. So in this case, you should use the top interface which connect with the linear connector. So this one we will connect with a tubing and connecting with very simple strings that can pumping the solvents quickly to the chip with a simple setup experiment. So that thing that I hope I can share the experience for you to solve the most common problems during the microfluidic the processing. It is the chip blocking or the contaminants during the experiment. Okay, so the presentation will be finished at this time. So if you have any question, please write down the question in the Q&A box. So next, we will move to the demonstration. Just I will introduce you a chip flushing kit. So from this one, I can show you how easily to make the chip flushing kits, which can very helpful for cleaning step and avoiding the blocking, or that can resolve the chip blocking if the chip blockage happens. So in my hand in here is the chip flushing chip. So flushing chip. So it will be including the edge interface or the top interface, it depending on the what chip you are using. In here, this one, let me remove this one. So this one is the edge interface that we supply as our standard product, and this one is the microfluidic chip with this one is the two reagent drop the chip at the chip junction size, larger chip junction size is 50 micron or 100 microns. So in this case, the chip can be connected with the tubing through the edge interface, and the linear connector, two linear connector in here and in here. So for the setup of chip flushing kits, so it's simply the connecting with the tubing like with the same experiment setup, but it's very simple way like this. So this one, for example, this one I made for using the chip resolving the chip blocking if your chip is blocked during your experiment. So the linear connector we connect with the tubing, and the tubing we will connect with the string that can pump contain the solvent in ensuring and pump the solvent into the chip in here. So it's through the connectors like this. So for the chip flushing, you connect the tubing with the same setup with the experiment, like forward direction. So input the chip will be connect with the tubing and the strings, and the outputs that making freeze, and there are some the holes that do not use, you can block with the blockage tubing. And after the experiment finished, just take out the chip from the experiment system and assemble in this flushing kit. So for this one, you just using the solvent to flushing it out with the high speed or high velocity of the solvent out to the chip. So during the repeating the process like this one, you can remove all the contaminant and all the ingredients with the solvent outside to the chip. In case of the chip blocking, if you want to try to resolve a chip blocking, you can do with connecting the tubing in the reserve direction. So the input of the solvent connecting with the tubing will be connect with the output of the chip, and let make a free the tubing with the input of the microfluidic channels. So during that way, you can using the syringe to flushing, to pumping, flushing out in the reserve way to remove the contaminant or dust that deposits at normally at the chip junction side. So by apply a little bit high pressures by using the syringe. So this is a very simple setup that you can make just only with the tubing, syringe, connectors, and linear connector at interface or top interface. So you can easily to make it and use it as a for the cleaning kit. Also remember that before the pumping, before the flushing the solvent, please also do pre-filter of those solvent or the solutions before the pumping into the chip to prevent any dust free of any dust or the contaminant into the chip during the cleaning step. Okay, so that is the demonstrations parts that I want to introduce you about how to make the chip flasking and how it can be used in flushing or cleaning chip at the end of the day, instead of using the system, those currently system, or for resolving the chip when your chip blocked during the experiment. So it's very simple kit and very helpful, very useful kit for cleaning. Okay, so now we are moving to the Q&A sections. So if you have any questions, so please write down your question in the question box. So I will try to directly answer you with the question. So do you have any questions? So I hope that this webinar section will help you we will help you to prevent any blocking, any unwanted issues that can be happen during as a normal common issues in the microfluidic experiment. For any specific applications, maybe it would be the following with the specific protocol, like for example, like you might need to use the combine of the solvent or mixture, I mean the mixture of the solvent, or you need to use some kind of heat treatment to help it can help to remove the contaminant out of the chip, or you can even though with the hydrophilic chip surface coating, so in case of you have to use the acid or base solutions, I mean for hydrophobic and fluorophilic chip surface coating. So the acid and base solutions do not compatible chemicals compatible with the chip. So in this case, you may use in some very special condition, like you can make up the droplet which contains the acid or base solutions, and continuous phase should be the organic oils or organic solvent or oil or fluorinated oil. So in this case, the acids and base solution will not directly to contact with the surface coating, and it's just only contact with the surface of at the chip interface. So in this case, it can remove all the contaminant at the chip surface, chip interface, the surface area. So without any damage in the surface coating after the post channels, I mean at the output channels. So it would be very helpful in some case. Do you have any questions? Yeah, I feel like there's no more questions. So okay, I got one question from someone. The 5-port manifold for chip flexing kits is used for which case? Okay, so the 5-port manifold for chip flexing kits actually is used for in case of the we use sorry. Let me show this presentation again with this one. Oh. Here, the 5-port manifold we use in case if we input the chip more than 3, for example, for like 5 input chip or not 5 input chip, for 2 reagent chip. Like for example, in here in my hand in now, we have 2 reagent chip. It means we have 4 input channels. So in this case, we should use the 5-port manifold to connect to divide enough the channels to tubing to the chip and doing the chip cleaning at the chip cleaning or chip fluxing step. So it's very useful. It's normally we use the just T connectors just enough for the if we use just 2-way input. But in case of the more than 2 or 3, we need to use a 5-port manifold. Is that clear? Okay, I got one question from Mr. Huang Kanrui. So if reserved washing doesn't work, what should we do? Actually, yes. Actually, we need to repeat reserve washing with a different flow rate or different pressure applied. That should lower than the limitation of the pressure. So in some case, you maybe need to do the heat treatment, like the warming up the solution, or using another solution or another solvent, try to remove or dissolve the contaminant out of the chip. So just try to repeat it several times to show how it can help to remove the contaminant. So finally, if the reserve washing, if the contaminant cannot resolve, so it means the chip is already dead. You cannot resolve or restore, reuse that chip. It's an unwanted phenomenon that we cannot solve that problem. So just remember that try to use the different solvents that you think is the help to remove the contaminant. And even though with the acid and base solution you can use, but with a different way. Like for the first time, just use this one without the oil contained phase. But if it can remove and it can make the line very small flow through the chip junctions, so in this case you can use the continued phase to protect the chip surface coating. Is that okay? Okay. Yeah. Thank you. Thank you for your question. So, is there any more questions? So, if you don't have any more questions, so I would like to finish today's webinar here. If next, maybe if you have more questions in the next time, just feel free to email us to so I can try to answer you by the email as well. Very happy to do the answering the question through the emails. So please contact with us through the email we post into the chat box. So thank you very much, everyone. So I hope that we can see you all again in the next webinar series that will be happening in last Thursday of next month. Yes, thank you very much, and have a good day. Thank you.